those four type of certification levels being certified, silver, gold, and platinum, are achievable in many different ways under particular criteria as called out by the USGBC in the lead or leadership in energy and environmental design. All right. So you can definitely check them out on their website and see what criteria is called for each of those. And they're very much achievable. Okay. So that's lead. Now, speaking more about the prints, while some electrostatic prints are still produced today, as you see, the majority of construction drawings are produced from digital files using wide format LED or laser and inkjet printers. Now, these wide format digital printers sometimes are referred to as plotters, and they use light emitting diodes or LEDs, as we all know them for. Also, lasers or inkjets to produce those clear and accurate construction documents quickly and cleanly, as opposed to historically that everything was done by hand on a drafting table. Now, uh, Jimmy, something to add? No. So now with the click of a button, you can print off multitudes of sheets in one project quicker, easier, faster. So that's an advantage of these digital prints that we have nowadays. But we may have lost some degree of artistic expression. If anyone's ever seen old architectural drawings, 1800s, 1900s, especially if you go to a museum in Chicago, they still hold a lot of these prints and artistic viewing, and they're simply beautiful. So if you haven't done so, I very much recommend it. But again, our digital frontier is what we're on, and printing LED style prints is very much the thing of the day. Okay. Coupled with that, we have computer aided design. And that computer aided design is also known as CAD or CAD or CAD, also known as computer aided drafting or computer aided drafting and design. And this utilizes computers to produce architectural drawings. And CAD systems are common in architectural and in engineering firms because of their efficiency and the quality of drawings that are produced. Now, architects benefit from increased drafting productivity achieved in the planning, the design, the drafting, and the reproduction of those prints. And CAD generated prints provide consistent line work, consistent symbol representation, and probably most importantly, consistent lettering. And you can see that here in this example provided to us by Roger A. Brooks Architect, showing us a section on the left-hand side. On the top right, an exterior elevation, and at the bottom, a detail. All right. Main takeaway is that CAD generated prints are going to provide consistent line work, consistent symbol representation, and consistent lettering. Okay. Do a double check, make sure we're not missing any questions. All right, we are not. Which leads us into a more sophisticated form of CAD. Some BIM modeling, right? So CAD systems, they're going to offer, again, many advantages for architects when developing their drawings, including the consistency and which I emphasize on. And that consistency can encompass uniform line width, symbol depiction, and representation of drawing components. It also includes an advantage of changeability. So revisions or any additions or deletions are easily made to that electronic file. CAD systems also provide an advantage in layering. So, and that's going to be a method similar to using overlays on conventional drawings in which their trade specific information is added to a base drawing to generate trade specific drawings such as mechanical plans, electrical plans, and plumbing. Another advantage that they also have is modeling. So, viewing a building in pictorial form and subjecting that model to engineering tests, such as a stress test, which you will typically see in a structural application, can also be a major advantage. Another advantage is it offers storage advantages. And drawings stored on an electronic media, such as a compact disc or a flash drive, consume less physical storage space than paper drawings. Another advantage is duplication. So you can have an unlimited number of prints, and those may be reproduced, each with original quality. Lastly, another big advantage that could be taken from this type of application is information management. Now, information about the materials used in drawings can be stored and also updated as drawings are going to be generated and changed, allowing the drafter to extract that information for takeoff purposes. Okay. Main takeaway is that modeling is going to allow a building designed to be subject to stress tests prior to construction. Here, in this example of Autodesk Inc. providing us with that CAD example. More importantly that we see now is BIM. BIM. And we have an example given to us here by Vico Software Incorporated. And BIM, if anyone hasn't heard of it, is short for Building Information Modeling. Building Information Modeling is an integrated electronically managed system that's going to align all working drawings, which is going to include your structural drawings and also your shop drawings in a consistent system. And Building Information Modeling, also known as Virtual Design in Construction or VDC, allows for integration of CAD generated documents or building models from various sources to create a complete set of construction documents. And contractors, your subcontractors, and your suppliers can all import the electronically produced construction documents or models into a common system that recognizes all of the individual construction components in a fully integrated platform. And now prints are generated from the integrated model that takes all construction components into account. And also that BIM technology allows for integration of estimating and scheduling software, which are very important, again, on the construction side, very much impacting the economics of any type of architecture. Okay, and that's BIM. BIM, short for Building Information Modeling. Any questions before we continue?
Is this PowerPoint accessible anywhere?
Uh,
Yeah, that's what I was about to ask.
yeah. So this will be provided for you before any test is given, and also right now the class is being recorded, so you can go back and watch.
Gotcha.
Got it?
Because I had issues with my Canvas earlier.
Right, right. Did that ever get resolved? I'm assuming not.
Um, Not on my devices. I
Okay,
had to borrow a laptop
okay,
before.
okay. We almost there, right? Almost there. Snail crawl, snail crawl. We'll get there. But yeah, that's BIM. And again, all what we looking at now is going to be uploaded at the end of class. Okay.
Thursday's recording. I couldn't find that. Is it
Yes.
also on Canvas?
No, I didn't upload. I just didn't have time at that moment later on the
No
evening.
problem.
And thanks for reminding me. Yeah, that wasn't open, so you didn't miss anything. Don't worry about that. Next, isometric drawings. Isometric drawings. Now, this is going to be a drawing which you're going to have three principal axes. They're going to be 120 degrees apart. Let me see it here. Three principal axes. Here, see it down, all at 120 degrees apart. These are isometric drawings. One dealing with sanitary, one dealing with water supply, but they both are isometric. So since the principal axes are at an angle, those three principal faces are going to be skewed. So, however, isometric drawings provide a realistic looking view of the object. And isometric drawings are commonly used for piping diagrams to depict the arrangement of piping in a building. Isometric drawing. But your main takeaway that I want you all to get from this one is that an isometric drawing is an axonomic drawing in which the three principal axes are 120 degrees apart. Next, perspective drawings. Now, perspective drawings are the most realistic type of pictorial drawing. And a perspective drawing is a pictorial drawing showing an object as it appears when viewed from a given point. And perspective drawings are commonly used as artists' renderings of a proposed building. And the rendering does allow a potential owner to visualize the overall appearance of the completed building and may be used for presentations to various zoning boards. These are your money shots. These attract and create appeal to any potential project that is wanting to be built. Okay? Perspective drawings. Another type of projection is orthographic. Now, an orthographic projection or multi-view drawing is going to be a drawing in which all of the faces of an object are projected onto flat planes, generally at 90 degrees to one another. This is different from what we saw in the ISO when they're at 120 degrees. But the front, the top, and the right side views are most commonly shown. And then the top view is always directly above the front view. The top view is always directly above the front view. And the right side view is always directly to the right of the front view, as you see here. So in orthographic projections, each view is shown two-dimensionally. Here, front view is showing our length and our height of our building. The top view is showing the length and the depth. And then the right side is showing our height and our depth. Any questions on these? All right. Line types. Line types. Now, line types used on drawings include your object lines. And we're going to zoom in here. Your object line, hidden lines. We also have center lines, dimension lines, extension lines, leaders, break lines, cutting planes, and section lines. For each one, your object line is going to be more thick and heavy in appearance. These are typically used to define the shape of an object. And hidden line, these are used to show hidden features, which we'll see heavily used in either elevations, sections, and or details. Your center line is used to locate the center points of arcs and circles. Dimension lines are used to show size or the location of objects. Your extension lines define the size and also the location, but in a more particular manner. As you see here, we have our dimension of 3 feet. Our dimension line is thin, and then the vertical part being the extension line. Leaders, you make use of calling out specific features. Break lines are going to show long breaks, but also could show short breaks. Your cutting planes are going to show internal features of an object. And then your section lines are used to identify internal features. Now, dimension lines are terminated by use of extension lines. Okay. Again, dimension lines are terminated by extension lines projecting from the feature being dimensioned. So here, this is a graphic representation of a window. We're saying with our dimensional line, from the edge of this wall to the center line of this window is 4 feet. It should only be 1 tick mark, not 2. 4 feet. And so you know that dimensions are added above a continuous dimension line or centered along it to determine and show the object's length or item to be called out. Now, those break lines are used where an architect wishes to terminate a feature or show that the feature continues but is not drawn. Here, we see break lines on the left and on the right. So this portion of the building is the wall, and it continues on down this way and also in this direction. But we're just calling out this section of it. So we do and understand that this break line is communicating to us that there's more wall and more information about this building, but we're only looking at this particular area of it. Anyone don't understand that? Good, because you will see it again. Again, your break lines. Now, another thing to point out here is the use of hidden lines. Hidden lines. So what it's calling out here is with use of those dashed lines that we came to understand in the previous slide, is calling out a particular feature in this wall. Can anyone tell me what that feature may be? It's a footer. That's right. It's a footer. For those who may not understand, and let's look at this cutting plane. This section or cutting plane is cutting through this wall looking to the left. So it'll be something similar to this. As the two wonderful people have mentioned, it's a footer. Some rebar in there. What's our footer? Ground. So if we're looking at floor plans looking down, it's calling out the edges of this footer to let us know there's more business going on below ground. Okay. Anyone do not get it? Speak now, forever hold your peace. Okay. Good, good, good. Now, scale. Scale is going to be our relative size to which an object is going to be drawn. Again, I mentioned last Tuesday the relevance of real estate on a sheet of paper. For drawing or depicting real life objects, the actual door is not going to sit on my 8.5 by 11 sheet of paper, my 11 by 17 sheet of paper, my 18 by 24, even my 24 by 36. A door is big, usually a typical size, 3 foot by 7 feet, or even 8 feet nowadays. So I'm going to make use of scale to draw smaller on my sheets of paper, but also communicate to the individuals in the building industry that, hey, this is at this scale. I'm also going to note it. It's supposed to be a certain size, but also you can make use of my scale to determine its actual size. So here in this example, we have a shelf detail showing us our dimension with our extension lines and dimension lines with notes telling us or calling out what type of material is being used, which is a 3/4 inch oak varnished. We have degrees being called out, hidden lines being made heavy use of, gyp board, short for gypsum board on 3/5/8 metal stud, 16 inches on center, which is this area in between, gyp board, break line, break line. So it is practical to create working drawings. It's impractical to create working drawings at an actual or even a half size. So working drawings must be created large enough to clearly show all necessary information, but yet must fit the drawing sheet specified for the project. That being probably 24 by 36 or 18 by 24. Okay. Now, an architect scale. So to use an architect scale, you want to place the 0 that we see here, either this one or this one. You have one on the opposite side. I'm going to place that 0 of the appropriate scale on one end of the line and then read the largest increment following on the other end of that line. Now, inches are read between the 0 designation and the scale size shown near the end of the architect scale. And the various scales can be read from right or left, not both. And scales that are multiples of one another are going to be shown on the same edge just to conserve space. So for example, the 1/8 inch equaling 1 foot and the 1/4 inch equaling 1-foot scales are located on the same edge. Here's the 1/4 inch, here's the 1/8 inch. So with the 1/8 inch scale read from the left to the right, and the 1/4 inch scale being read from the right to the left. Okay. So if I start at 0, I'm saying each foot, it would be 1, 2, 3, 4, 5, 6, 7, 8 feet. And then you can use these to get a more detail on inches. Okay. That's your architect scale. Another type of scale is our engineer scale. And our engineering scales, again, is another triangular 6-sided scale used to draw and measure large areas such as your building lots on your plot plans, civil drawings as well. And scales on an engineer scale range from 1 inch equaling 10 feet, 1 inch equaling 20 feet, 1 inch equaling 30 feet, 40 feet, 50, and all the way up to 60. So since engineers scales are used for drawing and measuring large areas, the inch divisions of a foot on an engineer scale are going to be omitted. Now, dimensions are going to be shown to locate points from other points on the print, and those extension lines again extend from a surface or other point of reference. And those dimension lines terminate or end on the extension lines and generally continuous lines with dimensions appearing above each of those lines. Now, a dimension may also be centered in a break line within that dimension line. And our arrowheads, our slashes, and our dots are going to be used as dimension line terminators. In this example, we have a wall to the left, which is being called out as being 12 inches thick. All this area in between. And then from that point to, let's say, this rail here is going to be 12 feet 6 inches. It could terminate as arrow, a tick mark, or a dot. That dimension in between two can vary. You can use 7'1" from here to there. It stops. This is going to be 4 inches wide. Continue on from that point on, from that last dimension, and then continue to your termination area of 5 feet. Add it all together, should give you, and will give you 12 feet 6 inches. That's that cumulative dimension, and it must equal your overall, our overall dimension. Cumulative, overall. Now, here's an example of a plot plan. You'll see this on our first example of our single family home called the brick veneer house. It will have a plot plan. Single family home, making use of a plot plan. And that plot plan is basically a scale working drawing that's going to show the shape and the size of a building lot. So it's going to show the location, the shape, and the overall size of a building on that lot, and the finished floor elevation of the building. Now, other information such as your setbacks may also be included on a plot plan as required by your AHJ, or authority having jurisdiction, or another name of a local ordinance. Since we're here in Tampa, you might have City of Tampa or Hillsborough County, or whatever county or city that you live in. Those will be the end-all, be-all authorities issuing inspections and permits. So in the example of this plot plan, we have a lot that is 126 feet and 4 inches wide by 90 feet and 2 inches. That will be your property line. All in red is your property line. You have contour lines on site indicating slope. Slope. So they're saying this contour line is at 3 feet. This contour line is at 1 foot. So it's sloping up this way, or sloping down, depending on how you want to see it. We also have vegetation or trees. We have utility pole. We have on the public side, we have existing sidewalk. And that sidewalk is 4 feet. 4 feet wide sidewalk. Have a little green space of 8 feet where grass will be. And our street curb. Our building on our lot that we want to sell or buy, we have 36 feet here, 8 feet, 14 feet, 30, cumulative of 36 and 14 being 50. And we go up to 38 feet. That is our building. And it's calling out that our first floor elevation is going to be plus 6 feet above the ground. We have an asphalt driveway coming into our living space or our plot or our lot. We have a garage and its elevation is plus 5 feet. So we have a foot difference between the two. So I can more likely go into here from my garage or walk out to go to the front door. So we have a concrete walk that is 4 feet wide, 6 feet back from the front of the building and entering into our space through the front door. To get a peek of what that looks like in plan, these are the plans for the brick veneer house. We'll do a side by side. Again, we're not getting heavy into the actual brick veneer plans, but to give you an idea of how diagrammatic this plot plan is, it will show. Let's rotate it. Here is that carport or garage, our main living area, sidewalk, walk through the front door. Yes.
Can you explain how the property line is identified? Since I don't think most blueprints aren't in color, right?
Correct.
So is the property line shown the image
On the left, no. So typically when you start getting a set of documents, you'll have drawings before you get into the floor plans itself, which will be a more blown up view, or your site plan or your plot plans. Right? Your plot plan will look more something like this, providing you how far those setbacks are. Right? So for example, the one on the right, it is giving us our setback here of 30 feet on the side setback, and the front setback being 30 feet. and then usually you'll get a rear setback. And those property lines are being denoted on what type of line it is. So we have a long line followed by two dash smaller lines, then a long one, then it repeats. Um, Also, another way to depict a plot plan is it look like as such, like we see here. Again, those line type, and then you'll have your dimension of each segment of that line. With this being a curve, it'll be more that goes along with this particular front yard property line. Did I kind of hit the question or get away from it?
Yeah. So the property line is defined by the setbacks.
The property line is not necessarily defined by the setbacks. The property line is really so defined by whoever's developing that lot in the city where it's being built. So, for example, I'm a developer. I go into Tampa and I buy 100-acre lot, and it's zoned for whatever it is. Uh huh.
Not the plot line.
Mm-hmm.
Property line.
The property line. Correct.
Yeah.
The plot line or the property line. You could say either or in this case.
Okay.
Right.
Did we mention what kind of line that was? The long line with the two dashes in it.
Yeah, that's going to be your property line or your plot line. Just say it's your property line. You'll be good. So here, zoom in. Your property lines. Okay.
Gotcha. Thank you.
Got it. You're welcome. Any other questions? Okay. Probably important aspect of your site plans or your plot plans is where your water and sewer lines are located. Usually they're going to be in the public right of ways. Why that is important is because you want to know where exactly you want to tie in to those objects to bring it inside your building, because you need water and sewer in your building unless you have uh, your on site generation of your own water or your own septic tank. Okay. Now, our floor plans is nothing but a plan view of a building that shows the arrangement of your walls and partitions as they appear in an imaginary horizontal section taken approximately 5 feet above the floor level. Some cases, 4 feet, you may hear. But floor plans are views of a building as though a cutting plane or cutting planes were made through it horizontally. So a one-story building requires one floor plan. And buildings with more than one story generally require a floor plan for each of those levels. And floor plans are considered to be one of the most used working drawings in a set of prints. Referencing back to your first set that you'll see, we have two plans shown on the first sheet. It will be our floor plan shown at 1/4 inch. Let's rotate that back. Floor plan at 1/4 inch scale, and also a basement plan at 1/4 inch scale. And your floor plans are considered to be one of the most uh, used drawing again in any set of prints. Your floor plans. Okay. Now elevations. Elevations are nothing but a scale view looking directly at a vertical surface. Now, depending on a building and the building size, is the building shape and complexity, four or more elevations may be required to clearly show the exterior walls. Generally, however, four exterior elevations are sufficient. You have the front, the rear, the right side, and the left side, or even the north, south, east, and west, depending on how they want to depict those or notate those elevated sides. And the north elevation of a building is going to be the elevation facing north, not the direction a person faces to see that side of the building. Again, the north elevation of a building is the elevation facing north, not the direction a person faces to see the side of that building. And elevations are going to be identified and the scale will be provided. Okay. Lastly, last slide for the evening. Interior elevations. Interior elevations. Here we have an interior elevation of the master bathroom. Now, interior elevations, they're going to clarify your size, dimensions, and locations of items such as appliances, fixtures, cabinets, mantles, and also bookcases, etc., etc. And the interior elevations in this figure show, again, our master bathroom. We have two vanities. Now, the floor to ceiling height in the bathroom is going to be 8 feet. See the dimension called out here. The walls are going to be finished with gypsum board. We have a water closet, and that's going to be installed between the shower and the vanity. And the shower has a glass door, and the vanity has two lavatories separated by an all-drawer unit. The countertop and the backsplash are going to be marble. And we have a medicine cabinets on each side of the mirror, and they're going to be hinged along the outside. Medicine cabinet, and that's called out. The hinge means it's going to swing out this way. Major takeaway is that interior elevations are nothing but orthographic projections of interior walls and partitions.